Okay, now let's look at some different forms for these vectors. We've learned about component form of the vector. Now let's look at two other forms. We want to look at a linear combination and what I call Trig form. So first, let's consider these two vectors, the I and the j. These are very popular vectors, and they're unit vectors. The I, of course, is just a vector that is a unit long, points in the direction, of the horizontal, has a 0y component, so it's just a horizontal vector. The j is a vertical vector, a unit vector. Now, think about this vector 3, 4. We could write this vector this way. Let me explain how that works. And this is the linear combination right here. This is a linear combination. Notice that if I thought about this vector 3i, in other words, if I took 3, the component 3 here, multiplied it by I, and then if I took the 4 and multiplied it by j, I would have this. Now notice what that means. That means 3 times this vector plus 4 times this vector. Well, if we multiply that out, we get this, okay? And then if we add those together, we get our vector back, 3, 4. So you can see that if you have a vector in component form, you can immediately write it in linear combination form this way. Just the first component times I, the second component times j. And I'll call this a linear combination. Now, trig form. Trig form looks like this. It's the magnitude of the vector times a vector cosine of the direction angle, comma, sine of the direction angle. Now let's see how this works. How can we write a vector this way? Well, let's think about a vector here. We've got a vector, it has a direction of theta, and I'll call this vector v. It's got components v1 and v2. Now, the horizontal, this x component here is down here. We get v1. Here's the y component, v2. And notice that we then would have the magnitude, of course, is the hypotenuse of that little triangle. This little triangle right here. Now notice that cosine of theta is adjacent over hypotenuse, which is v1 over the magnitude of v. And if I multiply both sides by the magnitude of v, I get this right here. See? Now I could do the same thing for the sine. I say, well, sine is v2 over the magnitude. And I get v2 equals this, just by multiplying both sides by the magnitude of v. Well, if that's the case, then notice this vector v1, I can substitute magnitude of v times cosine theta, and v2 I can substitute with magnitude of v cosine theta, and I get this, trig form. And let's look at an example here. Let's suppose I have this vector, v, and I want to write it as a linear combination. Well, that's easy. See? Just take the x component times I, the y component times j. There it goes. There's the linear combination. Now, as far as the trig form, we need the magnitude. So I'm going to get the magnitude of v. The square root of 3 squared plus 1 squared, square root that, and I get a 2. Now I need the direction angle. And remember, the direction angle is the inverse tangent of the y component over the x component. And of course, we know that to be pi over 6. We can get this from the unit circle. Okay, so we get pi over 6. So now we have the magnitude and we have a direction angle. That means this vector v can be written as 2 times cosine pi over 6, comma, sine pi over 6. And this is the trig form.